those are your two imaginary solutions. But the point of those first three problems is that there's always two solutions. Sometimes they're both real, sometimes they're both imaginary. They're never mixed in a quadratic. They're either both real or both imaginary.
Mhm.
Is there anything on that you'd like me to clarify?
No, so actually, so every single graph that it shows, it's always going to have two solutions, even if it doesn't touch like two things.
So we're gonna get to the one last case in number 3, but if it crosses twice, that's two real solutions. If
Mhm.
it does not cross, that's two imaginary solutions.
Okay.
That's like your Quizlet if you're trying to figure out what they could ask you on the test. It's kind of like a true false or
Yeah.
multiple choice fill in the blank thing. Okay, so for number 3, you might sit here, well, say, Matthew, that this looks like an exception. It touches, it doesn't cross, it touches. This is what's called a double root. So there are still two solutions. They just happen to be the same. And they're both real. And so to summarize, there's 3 things to remember. You have to remember, if it crosses, there's 2 real. If it does not cross, there are 2 imaginary. That's what we saw in this one. And if it touches, bounces, maybe you like the word bounces, then there's 2 real, but they're the same. It's called a double root.
Okay.
These are just definitions. There's no exceptions.
Yeah.
Nothing else there. There's a bit more I could say, but I'll see if it comes up later on in the lesson here with the problem sets. But we'll just move to problems 4 through 6. So for 4 through 6, you're solving using the square root property. Okay, and you've probably done this in class. You're going to take the square root of both sides of the equation, but you have to remember to write plus or minus on the non-variable side.
Yeah.
So there's always 2 solutions.
Okay.
So this is plus or minus 10.
Mm-hmm.
Okay. Now, is it okay if I modify question 5 slightly?
Yeah.
Okay. It's too much like question 4. So let's say this is actually negative 64. Okay, and they want you to solve it. So you still do the same thing. You still take the square root of both sides. It's still plus or minus the square root of negative 64. Okay, but the difference is now these are not real solutions.
Yeah.
Because there's going to be an I in it, because this is the square root of negative 1 times 64. And plus or minus, still plus or minus square root of negative 1 times the square root of 64. So your G is now plus or minus I, because I is the square root of negative 1. The square root of 64 is 8. That 8 generally goes before the I. So that's the 2 solutions, 8I minus 8I, like that.
Yeah.
And in your next chapter, you're going to end up going backwards using these solutions. But for now, we'll just go with that. So you just take a square root of both sides. All right, so number 6. Look at this together here. So in the previous 2 problems, it was just the variable squared, but now it's the variable inside parentheses squared. So what you don't want to do is you don't want to try to foil this binomial. you want to just undo the square. And so sometimes students ask me, they're like, hey, how do I know when to use the square root property if it doesn't tell you? You should only see the variable one time in the problem,
Mhm.
in one position. And that's how you know when to use the square root property. So you're
Okay.
going to take the square root of both sides, plus or minus the square root of 16. So we've got y plus 2 on the left, on the right, plus or minus 4. And this is where my preference would be to write them out separately and try not try to solve them together. So you would subtract 2 from both sides, and y equals 2. Subtract 2, y equals minus 6. Do you want me to give you one like any of these? Maybe a little more difficult?
I think I get these ones.
Okay. All right, so we're gonna start. So the next grouping is 7, 8, 9. We're actually gonna start with 9, believe it or not. So the very first type of factoring that you should learn is greatest common factor. Greatest common factor. And if you haven't been told this, you look for greatest common factor if there is both a number and a letter that goes into both terms. And you look for that first. So what I see here is that an M goes into both of these. Now, what you do not want to do is divide by M. You want to factor, not divide.
Okay.
So from here, the next thing to do is to write each factor equal to 0. And it's called the zero product property, but you don't need to know that, but you do need to know, hey, I got to write each of these equal to 0. So M is either 0 or M is minus 4. Any questions on that? Do you want one like this to try?
Yeah, maybe one more like that.
Okay, so let's try this. Let's go 4x squared minus 2x equals 0. Notice they are both equal to 0, equal 0 and equal 0. They have to be equal to 0. Okay. So what can you factor out of both of these? What's the number and the letter that goes into both?
2x.
2x. Okay. So if you're not sure what to put inside the parentheses, you're dividing both of these by 2x. That is sometimes a shortcut here. So 2x minus 1 equals 0. And then you set both factors equal to 0.
Yeah.
Okay, so on the left here, you're dividing by 2. On the right, you're going to add 1 and then divide by 2.
Okay.
And that is your final answer.
Yeah.
Any questions on that? I know I said I would give you one to do. I can give you another one or we can move on.
No, I think I'm good on that one.
Okay. All right, so we're going to move to actually question 8, and there is a method to this for why we're doing it in this order. If you were to look at the left-hand side, like if you were to ignore this equals 6 for the moment, you might say, hey, Matthew, this looks exactly like 9. I'm going to factor out an x on both. And you would be correct if there was a 0 here, but there's not. Okay, so you always want 0 on one side of your equation. 0 on one side of the equation, 0 on one side of the equation. You want 0 on one side of the equation. So we're going to subtract 6 from both sides. And this is x squared plus x minus 6 equals 0.
Okay.
Now, the greatest common factor doesn't work here because not everything has an x and not everything has a number that goes into it. So the next type of factoring is a trinomial into a pair of binomials. And because there's a 1 in front, this is called the a equals 1 type. You're trying to find two numbers that multiply to minus 6, but add up to positive 1 there. Any idea what those numbers are? Do you know how to figure those out?
Yeah. I'm trying to think of I think would it be 3 and -2.
Yes. So those are the correct ones. I'm going to go ahead and just list them all out just so you can see how to do this if you're not sure. One's positive, one's negative, and then you have to flip them. And then you just go in order here. Like you go from 1 to 2, 2 goes with -3. And then you stop when you kind of wrap around on this list. So each of these numbers goes in the binomial pair. Any idea what to do from here?
You set both equations equal to 0.
Yeah, both factors get set equal to 0. And then you solve each of them individually.
Yeah. Okay.
All right, so now we're going to look at number 7. So the 7 has 0 on the left side. If you don't like it there and I don't like it there, you can just move it to the right. That's okay. It's a symmetric property. Maybe you saw that in geometry. But you have to set the equation equal to 0. Now from here, this is just like the previous problem. So I'd like you to try factoring it for us. Two numbers that multiply to 4 but add up to -4.
Hello.
Hey, Isabel, do you have an answer for me?
Oh, so I actually did not hear anything you just said, and then it disconnected me, and I was trying, and then I was on.
Oh, okay. Okay. Sorry, I didn't notice. I was asking you to try factoring this one on your own.
Oh, okay, okay. So
Two numbers that multiply to this 4 on the right, but add up to -4 in the middle.
yes, so it would be -2 and -2.
Yes. And so this is an example of a double root because they're both the same value. Now, some instructors are okay if you just write x equals 2. Some want to see both. I don't have a preference, but that is the case here. So this touches the graph at x equals 2.
Yeah. Okay.
All right, so let's look at number. Actually, we're going to come back to 10. We're going to go to 11. No, we're not going to go to 11. We're going to go to 13.
Okay.
So the instructions say to find the zeros of the quadratic. And what that means is you're going to set the function equal to 0. When it says to find the zeros, determine the zeros, I never really like the word find, calculate the zeros, you're going to set it equal to 0. And it says you may use any method. So let's go through some of the methods that we've talked about today. We've talked about greatest common factor. We've talked about the square root property. And we've used this like a equals 1 factoring. Is that okay?
Yeah.
All right, so this is, I think this is a really important skill, is like determining which method to use to solve this. And you just kind of want to go down a list here. So what do you think? Which method of these three makes the most sense for this problem?
I think probably a equals 1 factoring.
Okay, so let's go look at the back of the ones that we did for a equals 1. Do you see how there are 3 terms?
Oh yeah.
3 terms.
Mm-hmm.
Okay, so greatest common factor works really well when there are less than 3 terms, but they both have a variable in it.
Yeah.
So let's look at this problem. Do both terms have a variable in it?
Yeah.
Yes. So greatest common factor would be the preferred choice here. So what do you factor out of both?
X.
X. And then you set them both equal to 0. So X equals 0 and X minus 13 equals 0. So X is 0 or X is 13.
Yeah.
Okay, so let's look at number 12 next. Whoa, that didn't snip the right place. Okay. So this is number 12, and it says to find the zeros of the quadratic. And that like what you want to associate with that is you're going to write it equal to 0.
I think you can use the square root property for this
Yes,
one.
exactly. That's what I was hoping you would say. So you're gonna move the 16 to the other side of the equation. And you can probably work it out from here. Can you give me the 2 answers for this problem?
So the square root of 16 is 4, so it'd be x equals plus or minus 4.
Yes, perfectly said. And you have to give both solutions.
Okay.
So identification is really important. That to me, that's what they're emphasizing here. It's, you know, the problem, it'll just say to solve. You may find on the exam that they give you like 3 questions and they say solve one problem using each type. Okay, but we're now doing 11.
Yes.
X squared plus 7x minus 18. You have to set it equal to 0. There are 3 terms. That's pretty good indicator that it is probably the a equal 1 type.
Yeah.
So now you want 2 numbers that multiply to minus 18 but add up to 7.
So it would be 9 minus 2 or negative 2.
Yes, positive 9 and negative 2. So that becomes x plus 9, x minus 2.
So that'd be x equals -9 and x equals +2.
Exactly. Any questions on sort of what we're doing there? What the,
No, I think I got it. I think sometimes I just get confused on like where to start. But
yeah. And so identification is key. Like these three methods, there are others, but we'll just assume these are the three.
mhm.
We did skip over 10. Now 10 appears to be missing an area of the triangle. Maybe it didn't show up in the scan. Do you happen to have the original picture?
That's exactly how mine looks on my paper form too. So maybe he did tell us to not do that one.
Yeah, just ask for the area. I mean, we could actually make one up here, but that's what's missing in this problem to be able to
Okay,
do
yeah,
it.
then we can just go ahead and skip that one.
Okay. All right, so we're gonna move to
And also we can skip number 14.
but 14 is the most interesting problem on the whole page.
Oh, well, if you want, well, I don't know. He was saying today because he was going over 14 because someone asked a question. He was like, I didn't even know how to do this when I needed to like actually sit down and do it because I was in a rush doing it. And he like didn't explain it to us, but we can do it if
We can come back to it. It's a good problem to do, but and I'm just kidding. It doesn't matter to me, but
okay.
it does have so it's a problem that you see in business students, business calculus. You know, I don't know if you've thought about like what degree program you might want to pursue in college. I know it's a little bit further away than now, but this is the kind of problem you actually would do. You would see again in that course. So
Yeah.
for whatever that's worth, you got a little extra on that tonight. All right, so we actually already did 15 earlier in terms of like how you handle a negative square root. Can you tell me the,
So wouldn't it just be no solution for all of these?
no. So the square root of -1 is I. So
Oh, yeah.
sorry, my screen just, this thing just stopped responding. So you have to treat this as the square root of -1 times 25. And then you break it apart. Square root of -1, square root of 25. So this one on the left is I. Square root of 25 is 5. It's preferred to put the number before the I.
Okay. Yeah. So then 16 would be 9i.
Yes. And once you know it, you're like, yeah, it's really easy.
Yeah.
Yeah, 16 is 9i for
17
sure.
is
17 is slightly more difficult.
Yeah.
So more generally, once you figure out, okay, there's an I and it's the square root of 32, you have to break apart the number using what's called a prime factorization. And you've done this before, just maybe it hasn't been this formal. But I'm writing the first few prime numbers out. So you start with 2 and you look, well, what 2 times what number goes into 32? And that's 16. And then you try 2 again, and you try 2 again, and you try 2 again. And this factor tree should have prime numbers on all the leaves. Maybe you've seen this before. I hope you have.
Yeah, we do this in class.
Okay. And then you circle pairs, and for each pair, you bring one out. So you're bringing out a 2, and whatever is left over goes back inside the root.
So that's the answer.
Well, it's the messed up, disorganized answers. The complete answer is this, and we should do another one here after this, but that is the complete answer.
Okay.
So let me give you one that's not as complicated that you should be able to do on your own here. I think. So let's go to the square root of -12. Why don't you try that for me, please?
Okay. So it would be 2i radical 3.
Yes, that's really fast. That's good. Can I give you one more, just a little bit more difficult?
Yes.
And it maybe looks more difficult than it actually is, but just if you could give that one a try.
Yeah. So if I have a pair of twos after and then the last one is 30 and it goes into 2 and 15. Since you have two of those, which one do you take?
So are you breaking it down this far?
Oh, I didn't do
So
that.
the idea is you actually keep trying the 2 until it doesn't work again.
Mhm. So which number out of the 3 and 5 do you take? Like, how do you know which one?
So you circle pairs. So like there's only one pair.
Mhm.
So all the other numbers on the leaves go back inside. So
Oh,
the two is the only one that comes out. There's an I, and then the 2, 3, and the 5 go back inside.
so then it'd be 30.
Yes.
Okay.
Do you want another one to do, or is that, do you feel like
Yeah,
that's
maybe
enough?
one more.
Okay, so let me have you try this one. The square root of -80.
So if there's two pairs of the same number, do you multiply those or do you just?
Yeah, they both come out. So you got down here, there's 2 pairs of 2s. So
Yeah.
they each come out.
Okay.
And so it's 2 times 2. There's an I because the negative square root of 5. So 4i square root.
Okay, that's what I got. Okay.
Okay, let's move on. You might make a note or put like a little asterisk there, and we can, if we get another lesson together, we can look at some more problems like that. So 18, 19, 20, 21 are kind of all the same. They want you to do math operations with this I stuff. This is actually kind of an SAT style question as well here. So with the parentheses are not needed. The only time you need a parenthesis is when there's an operator on the outside that does something. Like we'll see that in question 20 and 21 where there's a subtraction in the middle. That's when you need the parentheses, but we actually don't need the parentheses in this problem here. You can just drop them. Okay. And you probably saw this in class. You add up the real terms meaning those without I. So you have to add up 3 and 5. And then you can combine the imaginary terms, 7i and 7i. So that becomes 9i.
Yeah.
Now, do you see on the page where it says you must express your answer in standard form a plus bi?
Mm-hmm.
What do you think that means?
I actually,
Would this be considered correct, what I wrote on the right?
no.
No. You have to do it in this order. A plus bi.
Oh, okay, so it has to be the actual
Yes.
number before the
Yes.
variable.
Yes. And like, it's just a preference, but you have to, I mean, you're being graded on being able to follow the instructions the instructor gives you.
Yeah.
Okay, so why don't you try 19 on your own, please?
Okay.
And I'll check you here in a moment when you got the right answer.
So it'll be 13 minus I.
It is 13 minus I. Now you could say 1i or 13 minus I, they're both correct.
Okay.
All right, now for 20, 20 is the first problem where you do have to deal with these parentheses. So there's this subtraction operator, and there's really a negative. That really means there's a 1 here, -1. So you're distributing this into both terms. And the most common one that students forget is the second one. So this is 6 plus 5i minus 4 minus 3i. So I like to draw the arrows or lines. Somehow you need to convince yourself that you've tackled both terms.
Okay. So it'd just be 2 plus 2i.
It would be 2 plus 2i. Perfect. So why don't you go ahead and try number 21 for us, and let me know when you get your final answer on that.
Yeah, I just got it actually. I got -3 minus I.
Yes. Perfect. Okay. Okay, so 22 and 23 are actually disguised versions of what we just did. You have to simplify the roots first, but they end up turning back into a problem like 20, 21, 22 that we just did. So let me snip in 22. Okay, so we need to reduce the square root of -25, 5i, minus the square root of -9, that's 3i, plus 9i. And so this time there's no zero term. You can just write 11i. I hope they're not telling you to do this in class. I think 11i.
Yeah, I think that's what he wants.
So why don't you try 20? Well, 23's got a little wrinkle in it. So let's look at that together. So the last two here, you probably know it's 7i minus 8i. But this minus 20 squared and minus 27, you've got to break it apart. And we haven't looked at one yet where 2 didn't work the first time, but 3 does. So there's one pair of 3s that comes out,
Mhm.
and there's a 3 that's left over. So it's 3i square root 3.
So then you subtract 7i from 8i.
Yes. So you have 3i square root of 3 minus I. Now this is where I think maybe this is something new. Your answer needs to be in this form a plus bi. So there's actually an I in both. So you actually want to factor that out. 3 square root 3 minus 1. But the I is actually supposed to go over here on the right side. Again, I don't, this seems like out of scope for your class, but this is probably what the instructor will.
Yeah. Okay.
Any questions on that?
No, I think we're
Okay,
good.
so before we move to the next grouping of problems, just this is you probably saw this in class, but we're going to start out with I is the square root of -1. Okay. Do you know what I squared is?
I don't think so. I'm not off the top of my head.
So if you were to square both sides of this above the equation above it, you would get I squared on the left and -1 on the right.
Okay.
And so we need that for the for the next problem here. So for 24, I'm actually going to start handwriting these because it's just taking too long to snip them. So you're gonna distribute this 5i into both. So it's minus 20i plus 10i squared.
Okay.
So what is I squared? It's -1. So you replace I squared with -1. And so you get -10, and that needs to come first according to our format here, a plus bi. You can always switch it at the end, but you never want to leave it with this I squared, and you're not factoring it out. You're using this substitution.
Yeah. Okay.
So do you want to try number 25 on your own, please?
Yeah. So would it be 9 minus 24i?
Yes.
Okay.
All right, so 26 and 27 are FOIL problems. So you just do the same FOIL that you're used to. So first, outer, inner, and last. Excuse me. You combine like terms, the outer and the inner. And then the last term over here, it's minus -1. And it's good in the beginning to write it that way. That way you don't mess up signs because it comes +1. 6 plus 1 is 7. There's your final answer.
Okay.
So why don't you try 27 for us? It's just another FOIL problem. And let me know what you come up with.
Oh, I forgot to square the I. That's where I messed up. So is it 46I plus 48?
So you have to put the number first, 48
Oh,
plus
40, right,
46i. Like your instructor may mark you off on that. It seems silly. I don't know. I mean, it's the rules of the game.
Yeah.
Gotta go with that. All right, you ready to look at 28 and 29?
Yes.
So these problems, they really like in terms of where they would fit on your exam. Well, actually, let me ask you this. Does this review reflect how the exam is laid out? Does it tell you like, are they in this order, kind of in an order? Do you get, or is it a different format?
I don't know if it's gonna be in the same order, but I definitely know that like all of these are examples of kind of questions that are gonna be on the test.
Okay. So the reason I'm asking is that this 28 and 29, they really belong back with the grouping of like 11, 12, and 13. Like you're
Right.
supposed to be able to look at this problem and be like, oh, I know how to solve it. It's square root property because there's
Yeah,
only
that's what I
one.
was thinking.
Yeah. The difference is that when you subtract 16 from both sides, you get x squared equals minus 44. And you're not supposed to be shunned. You're not supposed to be like, oh, I don't know how to do that. You're supposed to be like, oh, I just square root both sides. And it's plus or minus the square root of negative 44. And I'd like you to try reducing that for us, please.
Okay. So it'll be x equals plus or minus 2 2i radical 11.
Yes, perfect. Yes.
Okay.
Do you want to try 29 on your own, please?
This fraction's kind of tricking me out.
Okay, so the first thing is to undo the fraction. You just multiply both sides by whatever number gets rid of that fraction. What would that be?
3.
3. And you should eliminate fractions immediately in almost every problem you see from the beginning. They're just a distraction.
Yeah. Okay. So x equals plus or minus 3i radical 5.
Perfect. Perfect. All right, so this is probably a good place for us to stop. Questions 30, 30 and 31 are completing the square. We did that in a lesson pretty recently, so those should be pretty familiar to you.
Yeah.
32 and 33, they actually refer back to questions 1, 2, and 3. So if we get another lesson, I'll remember to point us back to that. And then solving systems, we looked at that briefly in a previous lesson also. So
Mhm.
you and I now have covered probably everything that's going to be in this test. So if we don't get another lesson in, go ahead and check out those videos and the notes that I sent you if you've
Yeah.
got questions. But thanks for letting me help you, and I will see you next time, whenever that is.
Thank you so much.
You're welcome. Have a great night. Bye now.
You too. Bye.